Hello friends, fellow mathletes. Today we will use the formula of we will learn the formula of integration by parts. Now integration by parts, as we know, is a technique we use when there are two functions and we have to find the solution. When there is a product of two functions and we have to find a solution. So let's just dig right into it. I have written the formula here. So let us assume there are two functions which are being multiplied and we have to find the integral of the whole expression. Like there is an integral f of x multiplied by g of x dx. Now let us call the function f of x the first function, and let us call the function g of x the second function. Okay. Now the integration by parts formula is a very simple formula where we will write the first function as it is, then take the integral of the second function and multiply it with the first function. Okay, and minus whole integral, and inside this integral we will have another integral, the integral of second function, same as here, multiplied by the derivative of the first function, f of x, derivative of f of x, and we will take the integral of this whole expression with respect to x. So descriptively, first function multiplied with integral of second function minus integral integral of second function multiplied by derivative of first function whole integral. So what this will do, it will help us solve the functions that exist as products of functions. The simplest example I have solved here is x integral of x times sine x dx. Now if I make x as the second function, if I take sine of x as the second function and x as the first function, then this expression can very easily be solved, because we know that from power formula that derivative of d over dx times x is equal to 1, or derivative of x to n is equal to n into x n minus 1. So that's the power formula of differentiation. So whenever there are algebraic or expressions or polynomial expressions, we will use these expressions. Most of the times we will make these expressions as the first function, and any other function that is being multiplied with them, if it's a trigonometric function, we will use it as the second function. So what will it do? It will eliminate the algebraic expression, the power x, the terms involving x and the powers of x. It will eliminate them and it will make our solution very simple. So I took x as the first function and cos of x as the second function, and minus integral of I've simplified it already, the integral of this function, integral of second function. We know the integral of sine of x is equal to minus cos of x. So I've already solved it here, and the derivative of the first function, d over dx of x, which leaves us with x cos of x minus x cos of x plus this d over dx will give us 1, and so and this minus sign will cancel out with this minus sign, and it leaves us with integral of cos of x dx. Now integral of cos of x is sine of x, so the solution is minus x cos x plus sine of x. So this is how we use the integration by parts method, okay, to solve integrals which have products in them. Now there are few techniques that few techniques and few preferences that we must always use. We know that no such function exists. We know that no such function exists whose derivative, no such function exists whose derivative is a logarithmic function. We know that. So, and we also know that no such functions exist whose derivative is an inverse trigonometric function. So we will always, whenever we have to choose between two functions, to which functions to be the first function, which function to be the second function, which function to be the f of x, and which function to be the g of x, first function, second function, we will always use the inverse trigonometric function as the first function, and we will always use the logarithmic functions as the first function. And if none of these two are involved in our solution, in our integral, then we will use algebraic functions, algebraic expressions as the first function. What it does is we have solutions to there exist derivatives of inverse trigonometric function. There exist the derivatives of inverse trigonometric functions do exist. The derivatives of logarithmic functions do exist, but the integrals of these functions do not exist. So similarly, if I try to make algebraic functions as the second function, what it will do, it will expand them. Instead of our solution converging to 1 or 2 or 3 terms, it will expand the solution. If I had chosen x as the second function, what it would have done here, it would have integrated x again and again and again and again. In the first iteration, it would have become x squared by 2. In the second iteration, it would have become x cubed by 3, and it would have expanded. Instead of the solution converging to one solution, it would have expanded to a very large solution. So we don't want such situations. We will try to eliminate as much terms as possible when we are using the integration by parts technique. And the second thing you need to learn about integration by parts technique is practice. You can master it very easily by practice over and over. You try to solve as many examples as possible. Some you may find the solution of, some you won't be able to find the solution, but but as much you practice, your skills with using integration by part techniques will improve. That's all.